All right, so 8.2 is where we're at here. We're talking about transformations of logarithm functions. And when we're looking at this, okay, we already know a lot about transformations, and a lot of this is the same, but I just want to show you what this looks like in terms of a logarithm function, okay? So here is a logarithm function, a base logarithm function, with several of the parameters that we're already familiar with. A, right here, is the multiplier in front of the log function part. And that, of course, is the vertical stretch. All right. What happens if A is negative? Well, the y value, if it's up here, according to the x-axis, the y value becomes negative, so it flops down here underneath. So that's a horizontal flip. A vertical flip as well. B is the other one here. So B value, again, a horizontal stretch by a factor of 1 over b. H is right here, again, the same as it always has been. That is the horizontal translation. It's not a stretch. It's just a movement, either left or right. So if it shows up as x minus, let's say, 5, that means you move 5 units to the right. So it's always kind of the opposite of what the sign is that shows up here. And then, of course, k, if we look at k, that is a vertical translation. And it's whatever shows up here. If this was plus 5 here, you would move it up 5 units. So the transformations are all the same as we have been using with the other functions. But the tricky part is maybe identifying with logs, just like it was tricky maybe identifying with exponentials and with quadratics and stuff like that. So I just want to give you a few examples here. So in your textbook, there has been a transformation here by one parameter to this y equals log of x graph. And so a couple key points have been given to you here. And if you take a look at this, this point has moved to this point on the red graph. And so it appears that what has happened, is this a translation? Is this a stretch? What does it look like? Sorry, go ahead. Okay, it looks like a vertical stretch, and that is true. Now remember, a translation means that the graph would have the exact same shape. It wouldn't be warped at all if it's just a movement left or right or a movement up or down. But this one definitely appears to be stretched, right? And what's interesting to note is that this value, which appears to be a 1, goes to this value, which looks like a 3. And so it looks like we have y equals 3 log x. Does that make sense? I'll use a different color there for you. But all of these values, if this was 1/3 times 3, looks like to be 1. And so on. And look at the negative values. Negative 1/2, okay, times 3 would be negative 3 over 2. That looks to be pretty accurate as well. So everything gets stretched vertically. What about graph 2? This one, okay, look at the two key points here. We've got this key point here and this key point here. Now, so this one here, y equals log 3x, I think is your original, right? Does that still hold true? Yeah. So this is y equals 3 log x, but something has happened to this one. Has it been moved over, translated, or has it been horizontally stretched or compressed in some manner? What does it look like? Yeah, it's definitely not a translation, just a movement. It's a kind of a compression here. And so it looks like, this point here looks like to be a x equals 10. This one is x equals 5. So it's been compressed by half. So the horizontal compression refers to the b value, doesn't it? And so if it's a 1/2, what is the b in this equation? It's going to be 2. Yeah. So I'm just going to write a 2x here. Does that look like it's okay for this blue graph now? It's okay? All right, so this blue graph now has been changed again. It's kind of tough to tell whether this is a translation or a stretch. But if you look, when the graph sort of comes out as x gets larger and larger, you can kind of see that it's a bit of a mirror, right? It's a little bit, it's very similar to this, to tell you the truth, but we have to take careful note here. Now, so what's happened? Let's take a look at the key points. Where are they? Okay, so we have a key point here and here. All right, so either this is a stretch or this is a vertical translation. Yeah, we've already done a stretch, okay, so it's probably going to be a translation, but how else do we know? And I want you to take a careful look right here. The stretch, you see the 0 doesn't change. When you multiply 0 by something, the 0 doesn't change. It's an invariant point. But here, the 0 has definitely changed. It has seemed to have gone up by, well, maybe, 1 unit perhaps, or maybe a little bit more than 1 unit. So if this has gone up here, it's not the same, then what is our movement here? That looks like from 3 to 4. So it looks like we have a vertical translation of a plus what? Plus 1. Good. Okay, so I don't know if I have a purple color, so let's just use yellow here. So we've got 3 log 2x. Now I need to put this vertical translation in, so this is going to be a plus 1 outside. And let's just put the brackets here so we're clear. So this is making sense so far? Is it good? Okay, finally, this graph here, what has happened to this purple graph now to get the orange graph? Well, it appears as though things have been moved to the right. Here's this is the vertical kind of line here. This y-axis has actually been moved over here. So everything has been moved over. It looks like it kind of converges over here, but it's just because of the nature of the graph. Really, if you take a look at all of these values, they are moving over. How many units? That's 5, 6, 7, 8, 9. So 5 to 9 looks like 4 units. So how do I change this? So finally, y equals, how do I put that? I have to put that in here somewhere, don't I? So y equals 3 log of, and I have to be kind of careful here, don't I? Tell me if this is okay. 2x, I'm moving 4 to the right, so I'm going to subtract 4. Does that look right? I heard a no. Okay, why not? Thank you. Yes, if you see this, the b value is definitely 2, but if this is not a factored expression inside here, then this is not the b value. So what I'm saying is that really this would actually look like this, wouldn't it? And then this is your b and this is your h here. So we want the h to be 4. So all we have to do is, and maybe I'll leave that there for now. All we have to do is this, brackets. Does that make sense? Maybe you don't need the second pair of brackets. Maybe you don't need them there. It's probably fine to leave them out. But so this is your a, clearly. This is your b. This is your h. This is your k. We good? All right. Okay. And that's all the parameters right there. That's all the transformations. And honestly, I think you probably have enough to do. There's a few examples that I would point you to. And of course, we will go to the textbook here. Let me just get to, here we go, the key ideas. Like I say, there are some little things that I could show you about finding a b value or whatever, but I'll let you discover that. And here's the general, there's the notes here on for this section. Okay, any questions? All right, so that's a short 10-minute or so lesson on that, and now you can go ahead and finish your other homework and begin the 8.2 now.